So the other people that aren't here can see this. Okay. So if you look at the first problem that I posted on Google Classroom, great.
Man, sir, at school, your handwriting was so good. No, not so much.
Don't talk smack, please. I'm already on edge this morning.
Because you're a bum?
Yeah, basically. I mean, I think that the not being able to shower part makes it much more so that I'm a bum. I'm slowly becoming more and more bummy. Okay. So we have this big polynomial, right? I didn't like that 0. Okay. And we're dividing it all. So if you see, we can have an exponent all the way up to 4, right? So and if we're dividing it all by x plus 1. So what we're going to do is we're going to use a process that we call synthetic division. Okay. So with synthetic division, what we're going to do is first off, we're going to put the bottom part, the divisor. I don't know why it does that, but oh my gosh. So x plus 1, and we're going to set that equal to 0, okay? So if we solve for x, what do we have to do there?
Move the 1.
So we're going to subtract 1 on both sides, okay? So x is going to be equal to -1. So what we're going to do is we're going to put that over here in the little box, our -1. That's going to act as our divisor, right? So now the next thing that we're going to do is we're going to put in the coefficients. And by coefficients, what do I mean exactly? Like, if you guys can remember what coefficient is.
Isn't it the variable that goes in front? Or the
Actually,
number?
not the variable, but the number.
No.
Like this, right? All these numbers in front of the variable, those are the coefficients. What about for x over 4? There's nothing there, so what can we assume we have there?
1.
A 1. So what we're going to do is we're going to list all of these. So 1, -3, -3, 11, and 10. Okay, so the process is we're going to drop down that first one, and then we're going to multiply 1 and -1. What does that give us?
1, -1.
-1. Good. So now what we're going to do is we are going to combine these two. So that's -3 minus 1. What does that give us?
-4? Or no, 4. Yeah.
Yeah, -4. -4. Okay, so -1. Now we're going to do is -1 times -4. So the idea is that we're always dropping down and multiplying, and then adding, dropping down, multiplying, and it's the same process over and over again, okay? So -1 times -4, what would that give us?
+4?
A +4. So again, let's combine these. -4 and -3 would give us a +1. So a -1 times 1 is -1. We combine these two. So that's 11 minus 1, which is 10. And then -1 times 10 would give us -10. And in the end, we see 10 minus 10, which would give us 0. Okay. So what the 0 does is that it represents it represents the fact that we have no remainder, okay? So we have no remainder when we have something like this. No remainder. And so what is our answer? Okay. It's all based on the things over here on the bottom, right? So we have a 1, we have a -4, we have a 1, and we have a 10. So all we're going to do is we're just going to rewrite this. But instead of having an exponent of 4, we're going to go down an exponent, and we're going to go down to 3. So our answer should be x to the power of 3 minus 4 squared, x squared, plus x plus 10. And that's it. How's that look so far? Complicated?
No, sir.
No? What about the rest of us? What do you guys think?
I'm gonna need my calculator. Oh God.
All right. Well, the process is the same. It's always the same thing, right? You're following the same steps, which is again, I'm just gonna make these up, right? -3, 1, 2, 4, 5. It's always about this number goes down, so we're gonna multiply -3 times 1. That's -3. Then let's combine these two. That's -1. That becomes -3 times -1 is 3. And then we combine these. That's 4 plus 3 is 7. -21. And then we combine them again, right? So that's basically the whole process that we're doing over and over again. It's almost like we're following like a little like, I guess you could say the arrows in a sense. I always see this in textbooks where it's like, okay, we drop this down and then we multiply and it goes over there. Then we drop this down and we have -1 and then we go over here and then we drop this down and so on, right? So I see that in textbooks. So it's that same process sort of happening over and over again. So let's do another example, just so we can kind of have a couple different ones. We have 3x to the power of 4 minus 7x to the power of 3 plus x squared minus 13x, or sorry, 18x minus 9. Okay, and all of that is going to be divided by x minus 3. So the first thing I want to do is I want to decide what's going to go into the square. What's our divisor there? If you guys can remember from the last problem. What would be the number that goes into that square?
-3.
We need to take, so we remember we need to take this bottom one and we need to set that equal to 0. Oh my gosh. There we go. X minus 3 is equal to 0. So if we solve that, what would we have?
X would be equal to +3.
It'd be what?
+3.
Positive 3. Yeah. So that's a number that goes inside the square. So whatever this is just going to be the opposite. So what about the numbers? What are the numbers that are going to go up here?
3, -7.
So yeah, 3, -7, 1, -18, and -9. Oh my gosh. Undo. There we go. And again, because for some reason. Okay. So what happens again, and let me do it in a different color. The process is we drop down this 3. And we're going to multiply. 3 times 3 gives us a 9. Okay. So now we're going to combine these two. That's -7 plus 9 gives us a positive 2. So 3 times 2 gives us 6. Combine those two, we're going to have a 7. So 3 times 7 gives us positive 21. Combine those two, and we have 21, or -18 plus 21, which is 21 minus 18 is equal to 3. And then in the end, we have 3 times 3, which gives us a positive 9. So -9 plus 9 gives us 0. Okay, so again, we have no remainder there. So what we need to do is write out our answer. And again, what we're going to do is we're going to take this exponent, we're just going to subtract 1. So 3x to the power of 2, 2x squared, 7x, and 3. That's our answer down there. Okay. So now I want to end with one that's actually going to give us a remainder, because I want us to see how to put that answer in. Okay. So we're going to have 4x to the power of 4, 3x to the power of 3, 20x to the power of 2, 17x, and 6. All of that divided by x minus 2. So again, the first question is, what's the number that goes into that square?
2.
A positive 2. Because x minus 2, we set it equal to 0. That should be positive 2. And the numbers that go in here, we would have 4, -3, -20, 17, and 6. Okay, so we're going to drop down the 4, and we have 8. Then -3 plus 8 is positive 5, which gives us 2 times 5 is 10. So that's -20 plus 10 gives us -10. Then we have 2 times -10 is -20. 17 minus 20 is -3. And 2 times -3 gives us, I thought that was supposed to give us a remainder. Well, let's just say, let me just switch this last number. Let me just say that this last number was 10, for example. So 2 times -3 is going to give us -6. And then we have 10 minus 6, which is 4. So in this case, we actually have a remainder, okay? And really the only thing that sort of changes that, we have a remainder. Oh my gosh. So again, our answer is written out the same. What we're going to do is, since our exponent is 4, we're going to subtract 1 from that. So that's 4x to the power of 3. And we have 5x to the power of 2 minus 10x minus 3. Now to write that remainder, all we have to do is we're going to write that 4 over x minus 2. Okay. That's pretty much it, because since we can't do anything with that 4, we're just going to say that that 4 still needs to sort of be divided by that x minus 2. Okay. And that's how we would write out that answer. Okay, so you guys